Okay, so this one, the type of motion known as a free fall, is the kind of motion that you're going to experience when an object is thrown and projected into the air, and it is going to be subjected to one and only one force. What force is that? This is the force that we call gravity. So you throw an object into the atmosphere, or we can just simply describe it as that. We can just describe it as the kind of motion that is experienced when an object is in motion with only the force, or with only under influence of the force of gravity, with influence from only the force of gravity. Yes, let me put it like that. So the only force that is going to be acting on this object that is free falling is the force that we call gravity. And we know to say, since gravity is constantly pointing down with a magnitude of 9.8 meters per second squared, or 9.81 meters per second squared, if an object is going up, it is going to be experiencing this force in the negative manner. That means it is going to be what? It is going to be negative 9.8 meters per second squared, or 8.81 meters per second squared. So whenever you throw something straight up, it is going to go up with only under the influence of the force of gravity. Then it will reach a maximum height where it will succumb to this gravity and it will come to a stop. Then it will start falling down again until maybe you catch it on the same level, or I don't know where it end up. It might be go a little bit down, or you catch it at a much higher point. But the main point is that it is traveling under the influence of gravity, and as it is going up there, gravity will be negative. This will be negative g. But as it hits a 0 meter per second mark in velocity here, it will start going down, and it will be charging down with an acceleration of what? Of positive g, like this. That's how simple free fall is. It is also motion in one dimension, but which one dimension are we talking about? We're talking about the vertical axis, vertical motion. So it can be in two ways. It's either you throw an object up, it reaches a certain height, it stops, then it starts coming down, or sometimes you start it, or it will start from the top. The motion will start from the top, going down, and since it's starting from the top, the value of gravity here will also be positive, like this. And it depends the condition under which this motion started with, the initial conditions of this motion. It's either they're going to tell you to say this object has been thrown, or this object has been released. When they say this object has been thrown, that means this object was given an initial velocity, which means it had an initial velocity which wasn't equal to 0. And if they tell you to say it was released, that means the initial velocity of that object was 0. Or if they say it was dropped, if you drop something, you're not applying any force. You're just letting it go. And as you let it go, it will start charging down under only the influence of gravity. So if they say it was dropped, that means the initial velocity is also equal to what? Equal to 0. So let me do this. On these conditions, we'll say our initial velocity is equal to what? Is equal to 0. But if they say it was thrown, that means our initial velocity, V initial, is not equal to 0. It will be having a magnitude of velocity that isn't equal to 0. So under this motion, the principles that are applied are those same ones of motion in a straight line, the Suvet equations, because those equations will say they are applied when there's constant acceleration, of which is the same even in this case. The acceleration that is experienced is actually constant. So we apply those same equation under this kind of motion. For example, let me give one example. Let's say if they give us a question to say a feather is dropped. A feather is dropped. I'll just write the keywords. From rest in a vertical vacuum tube. It takes 0.5 seconds. So it takes 0.5 seconds to fall to the bottom. So it takes 0.5 seconds for this guy to hit the ground. What is the length L of the vacuum tube? What is the length L of the vacuum tube? So they've given us to say this is the time it took this, or this feather from the time it was dropped to the time it hits the bottom of the vacuum tube. Now they're asking to say what is the length of this guy. So let's now identify the data that have been given. Since they've said it was dropped, that means the initial velocity is equal to what? Is equal to 0 meters per second. And since it's going down, that means there is a force of acceleration, which will be equal to what? It will be equal to 9.81 meters per second squared. What else, or what other information do we have? We have 0.5 as the time. That's this fee that takes from the time it is dropped for it to run the whole length of the vacuum tube and hit the ground. Now they're asking to say what is the length of the vacuum. So which equation are we going to use? We're going to use a Soviet equation, which we said S, which is displacement, will be equal to UT plus half AT squared, where U is the initial velocity, T is the time, A is the acceleration, and T is time again, and S is the displacement. So this is in the y-axis. So we're going to replace this S with L, since we're looking for L. This will be equal to U. U is the initial velocity. Initial velocity is 0, so we're going to have 0 multiplied by the time, which is 0.25. Plus, it's a plus because this object is going down, so it's charging along the force of the direction of the force of acceleration or the force of gravity. So the gravity here is positive. So plus half 9.81 this is squared, sorry, 0.25 squared. The equation is ut plus half at squared. So plus half multiplied by 9.8 multiplied by 0.5 squared. So this equation is going to be automatically taken out. That means my length of my vacuum tube is half multiplied by 9.81 multiplied by 9.81 multiplied by 0.5 squared. And if I plug this into my calculator, my length of my vacuum tube will be equal to 1.2 meters. 1.2 meters. So that's one of an example of a question that you're expecting to find under this topic of free fall. Sometimes they'll ask you to say an object was thrown up from the top of the building and it reaches a certain height, it goes down. You are supposed to apply the same knowledge like this. Let's say, let me give an example of a scenario. At least the normal diagram will do. Okay, let's say this is a building, then this is a ground. They tell to say someone throws this into the atmosphere, then as it is falling, it just misses the edge of the building. It just misses the edge of the building and it falls to the ground. Sometimes they'll ask you to say what is the height of the building. How much time does it take in the atmosphere? So these questions are all simple to answer because you know to say from the time it is launched on the top of the building to the time it is going to reach its maximum height, it is going to have a v final velocity of what? Of 0 meters per second. And you're able to calculate the time this object takes to reach that height because you know to say the gravity will be negative g, which will be equal to negative 9.81 meters per second squared, like that. And you will also be given the initial velocity, for God's sake, which in this case is I'm just explaining for you a scenario. We can just put whatever you want. So you'll be given such scenarios. They'll ask you to say calculate the height of the building. You calculate this one. Then you also take the motion from the top of the building up to the ground. Using this one, this data up to that point, you can calculate the distance, the maximum height that this guy is going to travel. And if you calculate that one, it will reach that point there. Then you're going to start there. And since you're starting from the top, your initial velocity now is the one which is going to be 0 meters per second. And your gravity will be positive. It will be positive 9.81 meters per second squared, like this. Then it will have a final velocity which you don't know. But using this information, you're also able to calculate the distance, the height from the topmost point there up to the ground. Then if you calculate this distance, you'll just say this distance you've calculated minus the distance that you calculated here, and it is going to give you what? The height of your building. So there are different ways in which they'll phrase questions here, but this is the knowledge that you need to apply. And ladies and gentlemen, those are some of the principles that you need to understand under free falling bodies.